So we have polynomials factoring by grouping notes. So let's look at our first step. First step is to write out the polynomial. If you need to, you can write it in the descending order, or you can already write it to rearrange your terms so that way you have at least a common factor between what will become our groups. So that is something that you can actually do if need be, is to rearrange them. So the second thing that you want to do is to actually break them apart into the groups. One thing to note, if this is a negative number here, technically you could make this a plus and it'd be a negative x inside here is what you're going to want to do. And that way you can pull out the -1 later on. So you group them, and then you're going to factor. Okay? So make sure there is a common factor at least in some of them, even if that common factor happens to be 1, and that's perfectly okay. So when you factor each group, you want to ask what goes into both terms. So basically you're dividing, and you're asking what can go into 3x and 2x. Well, 2x, or the smallest exponent, can go into both of these. So you're going to divide it by 2x. So 3x divided by 2x is x to the 3rd divided by x to the 2nd is going to be x to the 1. And then x to the 2nd divided by x to the 2nd is going to be 1. And then over here, you basically can just pull out the 1. And it obviously isn't going to change the value to divide by 1. So what's going to happen next is really where the whole factoring by grouping really kicks into place. And what you have is that we have a common binomial that we are going to then factor out from both of these. So this whole entire group here, we're going to divide by x minus 1, which means it's going to cancel, leaving us with an x squared. And over here we're going to do the same thing. We're going to divide by x minus 1 and leaving us with a plus 1. So we get this answer here. So we factor out the common binomial that both terms have. And then one way to kind of think about it, if I was to take this group and redistribute it and multiply it by each term inside this other set of parentheses, I would get what's up here. I'd have x squared times x minus 1 plus 1 times x minus 1. And that's what you want to have. This is the same concept as the distributing by a group, where you take this whole thing and multiply it by each term in here. Okay? So once you've done that, this is where kind of a whole nother phase kicks in, which is checking to see if you need to factor it any further. So whether, and in our situation it's going to be no, because we're going to look for, is it a difference of 2 squares? No. It's a positive. That's not squared. Okay, is it a sum of 2 cubes? No, not an 8. That's not a cube. Nothing going on there. Is it a difference of 2 cubes? Nope. So we're looking at, is there any other way that I can simplify and factor this some more? And our answer is no. So if it was yes, then you would factor again if needed. Just a little bit of a reminder that 1 can be written as 1 squared, or 1 to the 3rd, or 1 to the 4th, etc., etc. So if I happen to have had x squared minus 1, I could have actually said that was the difference of 2 squares. And I could have gone from there. Or if it was x to the 3rd plus 1. Then you're going to say, okay, well that is actually could be rewritten as the sum of 2 cubes. So that's a little thing to remember about 1, is that it is very versatile between the different exponents. All right, So some other little bits of things to remember is that you do have perfect square trinomials do and can come up for in terms of simplifying. That a plus b squared would give you this quantity here, or a minus b squared, the square of those difference, the square of this sum would give you these different quantities here. And another little bit of reminder information when it comes to factoring is that you would use the largest number that goes into the coefficients and the smallest exponent that can go into all of them. So here we have our example. Well, the largest coefficient that goes into 15, 18, and 6 is 3. But for my exponents, I need the smallest exponent, which would be x squared, because x squared can go into x to the third and it can go into x to the fifth, and you just divide everything by this quantity here. Okay? So just a little reminder, and if you wanted to, you could actually apply it. If you wanted to truly simplify it, you'd get 3x squared times 5x to the third plus 6x plus 2. All right, I hope this helped.